Hello, sir.
Ma'am, Anita ma'am, are you able to hear me? Hello.
Yes, sir. Yes, sir. I can hear you. Sir, can you hear me?
Yeah. Yes, madam.
Okay, sir.
Shall I wait, madam?
Yes, sir. We will wait for another 2-3 minutes.
Okay.
Yes, sir. Uh, Sir, I made you as presenter. Can you please check whether you can present your screen?
Yes, 1 minute, madam.
Yeah.
Are you able to see?
Yes, sir. I can. Yes, sir. I can. Sir, we have got 70 number of participants approximately.
Okay.
I hope that we can start our session. We are expecting our registered participants are 593, but generally the number of sir some other screen is visible, sir.
1 minute.
Yes, sir. But we are expecting at least 450 participants, 450 to 500.
Oh, that many
Yeah.
participants registered. Yes,
Yes,
yes, sir. Even in native future also is going on the same day it is started. There
Yeah,
are also
yeah.
some 700 participants registered. Yeah, if it is online, it is different.
But the number of participants interaction was also very excellent, sir. They were very much actively participating. So already 80 people have joined, sir. So shall we go for our session, sir?
Yes, yes, yes. We'll go.
Okay, sir.
Okay.
First page of your PPT, if you keep, it will be good, sir.
Yes, yes.
Thank you, sir. I can see you. Good evening, one and all who are present here. I welcome you all for this Day4 ATAL sponsored 6 days online FDP. And today is our Day 4. And we are here to welcome our resource person, Dr. Venkatesan, sir, who is from NIT, Puducherry. Let me give him a short bio about our resource person. Dr. Venkatesan Meenachi Sundaram is an esteemed academician with more than 25 years of teaching and research experience in the field of computer science and engineering. He is currently serving as associate professor and head Department of Computer Science and Engineering at the National Institute of Technology, Puducherry. His area of expertise includes database systems, data mining, data science, big data, geospatial data science, machine learning, and image processing, followed with the natural language processing, generative AI, and quantum computing. He has successively executed several funded research projects supported by the premier organizations such as DST, ISRO, ICPS, DST, and has significantly contributed to the advancing research in cutting edge domains. With over 40 peer reviewed journal publications, 29 conference papers, and multiple book chapters, Dr. Venkatesan sir has established a strong academic and research profile. Notably, he holds a German patent for developing a system that accelerates fake news detection using quantum machine learning. Excellent, sir. A senior member of IEEE and active member of ACM, ISTE, and CSI, he has played important academic leadership roles, including the head of the department, research coordinators, and industry consultancy coordinators. His international collaborations, invited talks, editorial contributions, and commitments to knowledge dissemination underscore his dedication to shape the future of education and research in emerging technologies. I welcome you, sir, and I wanted to add one more point that sir is an ex-VITN. Welcome you, sir, and over to you.
Thank you, madam. Are you able to hear me?
Yes, sir, we can hear you.
Yeah, so very good evening, Dr. Anita Madam and Dr. Eglandeshri Madam. Thanks for this opportunity. So I used to say only V got replaced by N. So always I am VATN. So now I am become an ATN. So there is no much difference. So I am happy to be part of VAT activities. So once again, I thank the Dean's Core and the organizer. So the topic which is given to me is predictive analytics for large databases. I hope this first 3 days people have studied various different topics on generative AI, and there are many topics I have gone through the schedule. Hope I will touch upon different topics today also, even though my topic is predictive analytics. So before going to this session, I want to know the people background and what do you mean by predictive analytics? I think participants can unmute and speak, or they have the
Yes, sir.
provisions,
They
or
can speak. Ah, they can.
yeah,
They can.
yeah, please. So what is your understanding about predictive analytics? Anyone?
Hello.
Yes.
So predictive analytics, nothing but the solution that we are providing after doing the analysis. It's like a prescription.
It's like a prescription. Okay. Your good name, madam? You are from?
I'm Dr. Surekha Jandra from Somaya College.
Okay. Thank you. Any other answer? Any other participant?
Hello, sir. This is Deepak Dikshit,
Or
assistant.
it is
Uh,
a
One by one,
it's
please.
it's a tentative analytics of the future, considering the past performance.
You are from? Yeah, professor, you are from?
I am from Institute of Technology and Engineering, Malegaon Taluka, Baramati.
Very good. Very good.
yeah,
Next one.
Sir, it is a predicting.
this is Deepak Dikshit from Ishan Institute of Management Technology, Greater Noida. Actually, my answer is same as a previous one told. The predictive analysis is based on historical data, and we to our tools then we analyze that for forecasting or analytics. For we have the past.
Okay, good. Next.
Sir, good evening, sir.
Yes, good evening, madam.
Sir, it is a predictive analysis of future by using the past datas.
Okay, good. Anybody wants to say anything different? So, what is the understanding as per your statements? There are 4 to 5 people, professors have given answer that you can use the historical data and then you can predict for example, you can use the past 1 year rainfall data and then you want to predict whether there will be rainfall tomorrow or not. Okay. So that is the understanding by the people. You are correct only. So here, there are different terminology which is coined by the research community. There is a term called data mining. There is a term called machine learning. There is a term called data science. There is a term called big data analytics. Okay. And these are the some of the new term. Now people are talking about AI, right? So altogether, if you see, the machine learning is the base. Okay, AI is the main one. You know that in 1943, the McCluskey they introduced the first ANN model. Okay, so ANN means artificial intelligence, right? You can say artificial neural network, right? So artificial neural network is nothing but one of the first AI model introduced in 1943 by McCulloch and Pitts. So what is the idea? The human has intelligence because of the brain functionality. So the research community decided to mimic the human intelligence. So they thought of building a model by mimicking the neuron functionality. That's why it is called as neural network. Okay, or you can call it as an artificial neural network, or you can call it as an artificial intelligence. Right. So then you had a term called machine learning. Right. So what is machine learning? The machine will learn from the data and will act according to the data. Correct. The machine will learn from the data and it will act according to the data. Then there is a term called deep learning.
Hello.
Right. Yes.
Hello.
Hello. Hello, ma'am. Are you able to hear me? Participants, are you able to hear me?
Yes, sir. I can hear you.
No, some
Yes,
voice.
sir.
Okay, right. So then there is a word called deep learning. Right? What happened? So in normal neural network, you used to have two layer, input layer and output layer. Then it is in case of MP neuron, and then Rosenblatt introduced the perceptron model, where you had a two-layer architecture, but still you are not able to accomplish some task by using two-layer architecture. So then you moved on three-layer architecture, where you got this backpropagation neural network. Right. So there you have input layer, hidden layer, and then output layer. Then further people thought that, okay, you can have many layers inside so that the learning will be more. That's why, you got the deep learning. And people have addressed about this generative AI. So what is the backbone of generative AI? The backbone of generative AI is the transformer. Okay. And it is a new deep learning architecture, you can say. So if you say deep learning, then there are CNN and RNN. So transformers comes under RNN, right? So if you look the backbone of this transformer, the backbone of transformer is neural network. So what I'm trying to say, the machine learning plays a crucial role. Okay, even though the topic is predictive analytics. Okay, so in machine learning, what are the three paradigms of machine learning we have? Anyone?
Three types, sir.
What are the three types?
Supervised learning, unsupervised learning, and reinforcement learning.
So if you say predictive analytics, which learning will be comes under predictive analytics?
For which, sir?
Which among the three, which learning is called as predictive analytics?
Supervised
Any idea?
machine learning.
Exactly.
Supervised machine learning.
Supervised machine learning is called as predictive analytics. So there are three types of learning. One is supervised learning, unsupervised learning, and then reinforcement learning. Among the three, the supervised learning, also called as predictive analytics. Okay, right? You got it. So you will discuss about this predictive analytics. So what is predictive analytics? And this graph everyone knows. You would have seen this diagram from the web. Even I too have taken from the internet, right? So you can see in the y-axis you have the values, and in the x-axis you have the complexity, or you can say difficulty. And there are different type of data analytics you have basically. Okay, one is descriptive analytics, and then second one is the diagnostic analytics, and third one is the predictive analytics, and fourth one is the prescriptive analytics. Somebody said that prescription, okay, in the beginning. So that is called as a prescriptive analytics. So these are the four different type of data analytics you have. In machine learning, you used to say supervised learning, unsupervised learning, reinforcement learning, but many people have not focused much on reinforcement learning. They are focused on supervised learning and unsupervised learning. Now, recent days, many people are also concentrating on reinforcement learning. Okay, but when we come to this data analytics, basically, I can say only there are two major categories. One is descriptive analytics, another one is predictive analytics. Okay, this diagnostic analytics and prescriptive analytics are added later. But basically, we have two types of data analytics, descriptive analytics and then predictive analytics. That descriptive analytics is nothing but dash learning. Which learning? Descriptive analysis equal to dash learning. Unsupervised learning. Okay. Your descriptive analytics is nothing but your unsupervised learning. Your predictive analytics is nothing but your supervised learning. Okay. So in descriptive analytics, the main focus is what happened. Okay. Just for example, I want to form a 3 cluster of my students. Okay. That is a descriptive analytics. And diagnostic analytics is nothing but why did it happen? Okay. That is called as a diagnostic analytics. And the predictive analytics is nothing but what will happen. What will happen tomorrow? Right? We cannot, you have to predict it. Okay. So that's why everyone says that, yeah, I predict it. So how much score Rohit Sharma will hit in the particular cricket game. So what we can do, you can develop a predictive model to predict the outcome. Okay, you want to predict the outcome, you want to predict the pattern. Okay, by using the previous pattern, you can predict the next pattern. Okay, for example, what is happening in LLM, large language model? Okay, you will have a give series of strings. Okay, and then you want to predict what will be the next word, right? That is what happening in LLM also, correct? So you are able to perform this predictive analytics by using building some predictive models. Okay, right? So I will be giving in this lecture, I will be talking about how to build a predictive model, a simple predictive model. Okay, all right. So I hope everyone have some background of machine learning, so that it will help me to explain you in very detail about how to build a predictive model. And then the last one is the prescriptive analytics. How can you make it happen? Okay, that is the prescriptive analytics, right? So the idea is moving from information to the optimization. That is the complete cycle of data analytics. So our job is not to discuss other 3. Our job is to focus on predictive analytics. Okay. So before going to this predictive analytics, you want to know the process involved in the predictive analytics. Okay. So what happens? You know that in data analytics, the data plays a crucial role. Okay, the data plays a crucial role, right? So how will process the data? How will use the data? Anyone? Yes. See, you want to build a model. For example, I want to develop a prediction model to predict the rainfall, right? So what will be the data I have to consider? I hope I am in
historical data for last, suppose 5 years or 3 years rainfall.
Okay, right. Then no, the question is, you may be using the historical data, that is clear. But whether you will feed this data as it is to your data analytics model?
No, we have to pre-process the data.
You have to pre-process data. What are the pre-processing will do?
Suppose some missing values are there or some null values are there. So we have to take care of those type of data. So we can use mean value to replace the missing or null values. So some this techniques can be applied to tune the final stage data.
Okay, so I understood that missing value is a one way. What are the other methods of data pre-processing?
Data wrangling.
Data
Wrangling or munging.
Oh, okay. Then next.
Appropriate sampling of the outputs for respective inputs.
Sampling. Okay. Then
Data discretization.
Outlier detection.
Okay, the data discretization, good. And then outlier deduction, or I can say noise deduction. Okay, then
Duplicate value removal.
Normalization.
Duplication removal, and somebody said normalization. Very good. So basically, what is the understanding? You cannot use the data as it is, correct? Whatever the data which you are collecting, the data to be standardized. See, there are different type of data. Basically, we have two type of data: categorical data and continuous data. Am I right? So whenever you go for this continuous data, there are some standard data pre-processing methods. One is, somebody said, missing value analysis, that is called as data cleaning. So when you say data cleaning, missing value analysis, and then noise identification, all this comes under data cleaning. Then you will do data integration. It means that the required data may not be available in one place. For example, I want to predict the rainfall. So to predict the rainfall, I need some wind speed, temperature, and so on. It may not be able to collect in one place, so I have to collect from different places, and then I have to store it in a single place. That is called as a data integration. Then somebody said normalization, which is also called as data transformation, transforming one form of value into another form of value. That is called as a data transformation. The last one is a data reduction. Okay, so you may be collecting a lot of data, but all the data may not be required for your predictive analytics. Okay, so what you will do in that case, you will take a subset of data. That's called as data reduction. Okay, so which is also called in recent times feature engineering, where we have two sub feature engineering. One is feature selection and feature extraction. Okay, so what I'm trying to say, once you collect the data, you have to knowingly or unknowingly you'll be applying this data pre-processing method. So you must know all the data pre-processing method. For example, a data transformation, where somebody said normalization. Normalization is one of the important data standardization method in the IEEE paper and all, which is referred as data standardization. Okay, so there are different type of normalization: min max, z score, and decimal by scaling. The z score is the popular method to standardize any continuous data. What it does, it transforms all the attributes into uniform scale values, large scale values into small scale values. Okay, so I request all of you to know about the data pre-processing in very detail. As I said, data reduction also a very important role. So in the data reduction, you have feature selection and feature extraction. In feature selection, if you have 10 attributes and you know that there are 5 attributes which are important, you will select that 5 attributes. That is feature selection. Feature extraction is nothing but there are 10 attributes, but you are trying to infer some 2-3 attributes, okay, from the existing 10 attributes. That is called as data extractions. So some of the methods are principal component analysis, and LDA, linear discriminant analysis, and then ICA, independent component analysis, and so on. By using any one of this method, what you can do this data reduction. The another name for data reduction is dimensionality reduction, right? So this task, okay, called as data pre-processing task. So once the data is ready, then you have to go for a data analytics, where, as I said, the supervised learning is nothing but your predictive analytics. Your unsupervised learning is called as descriptive analytics. So you have to choose which analytics you are going to apply based on your problem statement, and then you can choose the particular data analytics method. Okay. So as I said, the predictive analytics, it's nothing but the supervised learning and machine learning. Okay, so what do you mean by supervised learning? What do you mean by supervised learning?
We are using generally labeled data set in supervised learning. Class labels are
Okay.
there.
Means the predictions
Good.
are known. We have to classify into predictions.
Where
Okay,
you
very good.
have human intervention for doing the prediction.
Good. Right. So what happens in supervised learning, as the answer is given by the participants, you can see here there are labeled data. Okay, so these are the data with the labels here. Okay, so you can see square and triangle, right? And these are the data you are giving to the
Sir, voice is not audible.
So you are not audible.
Video presentation is stopped.
Not able to see the slides.
Participants, inform to Sir. Sir is now joining. Okay.
Okay, ma'am.
I did not notice that some disconnection has happened. Okay, thank you.
Yes, sir. Okay.
I will share it. I will share the screen.
Yes, sir.
So where I stopped actually, because I'm continually speaking without noticing this.
The label data supervised learning.
Okay, okay. Right, right. So in supervised learning, we'll have a data along with the labels. So it will be given to the machine. So the machine will understand, okay, if this is the data and this is the label. So if there is something data, if you supply without label, then the machine is able to predict, okay, what kind of label it is. That is called as a predictive analytics, or you can call it as supervised learning. So understand, with respect to data analytics, it is called as predictive analytics. With respect to machine learning, it is called as supervised learning. Both are same. Okay, in Google, just type top 10 predictive model or top 10 supervised algorithm. Okay, both will be same, right? So there are different type of predictive analytics methods. One is linear classifier and parametric classifier, non-parametric classifier, non-metric classifier, and aggregation classifier. The linear classifier, parametric classifier, non-parametric classifier, and non-metric classifiers. These techniques are, it will, the model will get developed by using this classifier, and sometimes the accuracy may be less. So you want to boost the accuracy. That's why you are going for aggregation model, which is also called as ensembling model. You would have heard about it. Okay, ensembling model. So one of the, there are stacking, boosting, and bagging. These are category of ensembling models. Okay, people are using it. So among the three, these two are very popular: bagging and ADA boost. Right? There are many XGBoost and there are many algorithm random forest and so on. But bagging and boosting are the very famous methods used for aggregation, or you can say ensemble models. So you know what is predictive analytics, what is supervised learning. So if you further divide this predictive analytics or supervised learning, there are two categories. One is classification, another one is prediction. One is classification, another one is prediction. So what is the difference between classification and prediction? Anyone? I said in supervised learning, you have two categories, classification and prediction. What is the difference between classification and prediction? When you
In
will go for
classification,
classification, yes, sir, please.
in classification, we divide the input data into separate classes, and in prediction, we obtain the predicted value depends on the historical data and input data.
Any other answer?
Sir, in classification, in,
Yeah.
in classification, we are sure and we know the results. So accordingly, we classify. Rather in prediction, we make a guess.
Any other answer?
Sir, in classification, we are classifying the input feature, and generally we are working on the category type of the data. And in prediction, we are predicting the value. Generally, we are working on the numeric type of data, like regression can come under a
Very good answer, madam. You are correct. So classification, mainly you want to classify whether the patient is affected by COVID or non-COVID patient. That is classification. So where normally what happens, the data will be represented in the form of information table. For example, you can see here. Are able to see there is a one data I am showing, the COVID data. Are you able to see?
Yes, sir.
So where you can see patient ID, fever, it's not cold, it's cold, and cough and body pain and COVID-19. So this is one sample data. It's a COVID-19 data. Sorry. So in this data, you can see there are always the data is represented in the form of information table, which consists two type of attributes: conditional attributes and then decision attributes. Could you please tell me which attribute is decision attribute here? What is the purpose? I want to classify patient as COVID and non-COVID patient. Now tell me which attribute will be a decision attribute.
So COVID-19 feature is a decision attribute.
Thank you, madam. Exactly. COVID-19 will be the decision attribute. Okay, because where you have yes and no. So based on that, you are going to say that whether the patient is affected by COVID or not. Correct. You want to classify it. So the attribute, or you can call it as the feature, which is used to classify, okay, your data is called as a decision attribute, or you can call it as a label attribute, or you can call it as a target attribute, or you can call it as class label attribute. What about the remaining attributes? Patient ID, fever, cold and cough and body pain, they are called as conditional attributes. Okay, so in any data, there will be many attributes, or you can call it as a feature. There will be many feature, and one of the feature will be the label feature, okay, or target attribute. Correct. If that label feature values are categorical, okay, here yes and no, okay, true or false, then you can always go for classification. Okay, if that COVID-19 is not the yes or no, it says some 50, 50, 60, 70, something like that. It is a numerical. If that label is numerical, then you can go for prediction, or you can, prediction is nothing but the regression. Okay, so understand, if the data decision attribute is categorical, the decision attribute values are categorical, you will go for classification. If the decision attribute is continuous, you will continuous, or you can call it as a numerical, you will go for prediction. But there are some algorithm, okay, there are some classification algorithm which works both categorical data and continuous data. That is also there. Now it is clear what I am trying to say. What is the difference between classification and prediction? So classification means the class label value will be categorical. Okay. Prediction means the class label value will be numerical. I hope it is clear to you. These are the examples for predictive analytics examples. Like, I want to predict the house price. For example,
sorry for interrupt, sir.
Yeah.
Sir, I am unable to see your PPT, sir.
Sir, you check your internet connection. His PPT and his audio is very clear.
Yes, sir. PPT is visible, sir.
Thank you.
Yes,
It
Thank
is
you.
coming
it is
on
visible.
D screen, sir.
Shall I proceed?
Yes,
Please
sir.
proceed, sir. Please proceed.
Okay. So now you can see there is a one graph where in x-axis we have the square feet and in y-axis we have the price. Okay. So if that plot, say for example, I want to buy a plot in Vellore. Okay. So if it is a 500 square feet and this is a price, for example, you can say it is 1 lakh, something like that. Just assume. Okay. But now the cost is very high. Okay. If it is 1,000 square feet, it may be some 1.5 lakhs, something like that. But now I want to know. So I have the values. You people said, right? By using the historical data. These are the data. If it is 5,000 square feet and this is the price. If it is 1,000 square feet, this is the price. If it is 1,500 square feet, this is the price. Like that, you have many data. But now I want to buy a plot of size 800 square feet. What will be the price? Okay. So this will be done by your predictive analytical model. You got it? Right? So this is the one example. Like that, image classification. This is also one kind of predictive analytical model, or it can call it as a classification model. Right? You want to classify. The input will be the raw pixels of the image, and the Y will be, you have to classify which object it is, whether it is a cock or whether it is a no inox. Like that, you have to classify it. And then even machine translation. Okay, now everybody is depending on it. When you're going to the foreign, you may not be able to speak in that language. So what you will do, you will use always Google Translator. Okay, right? So English to China or English to Taiwan, something like that. Okay, so these are some of the applications comes under predictive analytics. Now, to understand very clearly about predictive analytics, what I am trying to do, I am trying to introduce a tool. Okay, and I want to teach you how to build one simple predictive analytical model. Okay, so before going to the tool, in the meantime, I will start that 1 minute. Let it get opened. So what I want to do, so when you are going to build, okay, it will come. So now let us build a predictive analytical model, okay, by using this COVID-19, right? So here, as I said, in predictive analytics, you have both classification and prediction. Now I am giving example for classification, okay, right? So now, as I said, this is the data. Now, what you used to do, how you do in so machine learning, what normally you will divide the data into training and testing. Okay. So when you are going to build a predictive analytical model, the first step is you have to divide the data into training and testing. Okay. Using this training data, you have to build the model. So always I used to say there are two-step process involved. Step one is how to build the model. Okay. By using your predictive analytical algorithms, or you can say supervised machine learning algorithms. So there are many ways. You can directly split the data into 80-20 or 70-30, like training and testing. But instead of doing manually, if you do manually, what is the problem? You may get some imbalanced data set. What do you mean imbalanced data set? The data set may not have all the labels, samples equally. Okay, that is called as imbalanced data set. So to overcome that, there is a standard method called cross validation, which is also called as cross K validation. Okay, you can call it as a cross validation or cross K validation. So what it does, it divides the data into training and testing. Okay, in cross K validation, I said K, the K is nothing but number of folding. If I say K is 5, then 5 folding will happen and the data will get divided into training and testing. So now the data is divided into training and testing. Correct? Now you will take the training data, you will apply your predictive analytical models, or sorry, predictive analytical algorithms, or you can call it as supervised machine learning algorithm. Okay. Once if you apply the supervised machine learning algorithm on the training data, you will get your model. Okay. Your predictive analytical model is ready. I repeat once again, the data is divided into training and testing. You will take the training data, you will apply this supervised machine learning algorithm on the training data, you will get the model. Now the model is ready. Okay. And I want to test the performance of the model, right? So how to test the performance of the model? By using testing data, right? So I will apply the model which built by using my supervised machine learning algorithm. I will apply this model on the testing data. Okay. Based on that, the model performance will be checked. Okay. We'll validate the model by using the testing data. For example, in Vellore, you have CMC. Okay. Now the CMC doctor, okay, they have given the complete COVID-19 data to us. Now what they told us to build, okay, a predictive analytical model or a classification model to classify, okay, whether the patient is got affected by COVID or not. Okay. So before giving this model, what I have to do? I have to test my model whether it is working fine or not. So whatever the model which I built, I have to test it by using testing data. If I say like this, it may be not clear to you also. So what I will do, I will show you in tool, okay, how to build the model. And if you need the algorithm further based on the timing, I'm ready to discuss 2-3 algorithms also. Okay. So, madam, shall I teach them in the tool how to build the model? Then, if time permits, we'll discuss the algorithm or what to do.
Yes, sir. You can give them the idea of model creation.
Okay.
And then we will discuss about the algorithm so that it will be easy for them to grasp. Thank you.
Okay. 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 So I don't know how many people, anyone knows about this tool, Altair AI Studio? Participants?
No, sir.
Anyone? No. Okay. So there are many tools, you know that after the introduction of generative AI, there are a lot of tools every day. So you are not able to recognize which tool to study. Am I right? So there are a lot of AI tools are available in the market. But this is a tool I am using this past 15 years. This tool is one of the graphical user interface tool. And everyone is now going towards no code, low code. Okay, you don't want to write a code because now generative AI is writing code. And even if you write a code, it should be minimal code. So this tool, maybe the participants may be a different background. They may be from different discipline like electrical or electronics also. Correct? So for such a people, this tool will be very good. Okay. So here, this tool, what happens, how they have built, they have converted all our the predictive analytical methods as the operator. Okay. So what you have to do when you want to build the model, you have to choose the appropriate operator and then you have to interconnect and we can build the model. Right. So how to build the model? This tool you can download. Just type in Google Altair AI Studio, go there and download and then use it. If you find any difficulties, please ping me in my mail ID. I will help you. Okay, because you have only another 45 minutes of time. So I need time to teach you this tool to build a predictive analytical model. Right. So I used to divide this environment into 4 areas. Okay, this white space. I hope you are able to see my screen, everyone. Please ensure.
Yes, sir.
Okay. So this area, this white area is called as a process area where you are going to build our model. Okay. And then the left-hand side, the repository area. The repository area always, you know that repository means to store your data, to store your model. Okay. So you can, what you can do in the local repository, you can know, you can save your model which you built. And this is very important. The left hand side, I hope you are able to see the operators. Okay. So in the operator, there is a small search box because if you know the name of the operator, directly you can search. Okay. But I don't want to tell you in the beginning. Now you can see there are many subfolders. Data access, Data access a folder where you can see, you can read the files and you can write the files. Read means you have read CSV, read Excel, read URL, read SPSS. So there are many provisions to read your data. Okay. If you're, for example, for understanding purpose, I kept my data is in Excel. Okay. It's not only that. Your data is in database. Yes, you can read database also. Or no, sir, I have my data in Salesforce. Yes, we can access it. No, sir, my data is large because the topic is very large database, right? So I stored in AWS, okay, cloud, and I want to access it. Yes, you can read data from the cloud storage like Amazon S3. But what you're supposed to do, you have to interface the Amazon S3. You should have a login in Amazon S3, and you have to set, establish a connection in Altair Studio. That is a some steps you have to do it. Okay. It's not only that, even you can have your data in Google Drive, and you can read data from Google Drive. So what I'm trying to say, this tool provides an option to read a data from various sources. Okay. But for understanding purpose, I'm going to read a data from local repository. So my data is in Excel. First, I will explain the data. Then I'll come back 1 minute. I will show you the data. Are you able to see my data? Excel? Yes. Okay. So you can see whatever data I have shown in PPT is same. I have patient ID. Then I have another feature, fever, cold, cough, body pain, and then COVID-19. Correct? Now, which attribute is label attribute in this data set?
COVID-19.
COVID-19 is the label attribute. Is it clear now? Now, I want to use this data to build my model. Clear? So this is a data given by CMC doctor. Okay. Now I'll go to the tool. So my data is in Excel. So I'll use read Excel. So how to do that? This is simple. You just double click, automatically it will be added in the process area. If not, you just drag and drop. Clear? So I have added this operator. What is the purpose of this operator? This operator is used to read the data. You keep your cursor on this operator, then immediately you can see in the right hand side the parameter window for this operator. Okay, it means that this operator has some parameters. For example, what is the idea? To read the data. So which file you want to read? Excel file. What you can do, you can load your, just you can browse and you can load your data directly. That is a one way. But what I used to say, don't do that. Whenever you go for supervised learning, you try to use this import configuration wizard. If it is unsupervised learning, you can browse directly, or instead of that, you can use this import configuration wizard. So click this. Now you have to load your data. Okay, next. Everything is fine. Okay. Now in this prompt, in this dialog box, you can see sheet 1 always by default. You know that Excel is made up of many sheets. So which sheet has the data? For example, if you are using some big applications and sheet 1 has one data, sheet 2 has data, then you have to specify which sheet has the particular data. And then the cell range you have to give. By default, it will be there. No need to do anything. Click next. So click next. And this is the important dialog box. What you are able to see here. Patient ID. Are able to see under each attribute, there is one drop down box. For example, see There is small drop down. Okay. So you can see there is a change type and then change role, rename column, exclude column. 1 minute. Okay. So you can change type means if you want to change the type of the attribute, you can change it. Change role means that is very important. What it means, what I said in supervised learning, you have to inform to the machine which attribute in your data is going to be the label attribute. So click this, you can able to see label, click this. Okay. Right. And apart from that, you can rename the column, you can exclude the column. Suppose you feel that that particular is not important for your task, you can exclude it. Okay. But as of now, I will keep it as it is. Then click finish. Now, how to read this data? So this is the operator which has input port and output port. You connect this output port to the result. In the right hand side, you can able to see the result. Okay. Now, how to run this process? Are you able to see this? There is a blue icon. Click this. Now you are able to read the data. Clear? Up to this is clear? How to? Yes or no?
Yes, sir.
Okay. So now what is the difference here? Why this COVID-19 is shown in different color? Because this attribute is
That is a label attribute.
label attribute. Okay. Now, so you are in result area. You want to go back to the design area. So what is it now? You can go back and see always this PPT so that it will help you. So what I did here, now I have read the data. This is done. What is the next step? I have to divide my data into training and testing. Okay, by using cross validation. So go back to the tool, go to the operator, just type cross validation. Okay, then add it here in the process area. Disconnect this, supply this data as input. And now, are you able to find the difference between these two operators? The read axle is the only small rectangular box. But what about the cross validation? What is the difference? What is the difference?
Different folds.
It looks the double line box, right? It is a single line. Here are you able to see double line, double box. So this is called as nested operator. If any operator is in this form, this is called as nested operator. What is nested operator? Operator as some more operator in it. That is called as nested operator. Like you say nested subquery in SQL, query within a query. Okay, right? So this is called as nested operator. So what it means, within the operator, you have to define some more functionality. So double click this. Now what you are able to see? What you are able to see? There are two windows. Are you able to see?
Yes, sir.
What is the two window? What are the two windows?
Training and testing.
Very good. Are you able to see training and testing? So I go back. So what I did, just I double click this operator. Then this operator divides, which provides two window. Okay, training window and testing window. And in the training window, you are able to see there is a one operator. There is a one operator TRA. Okay, it means that what it does, the cross validation divides the data into training and testing. The training data is available in this training window under this training port, TRA port, and testing data is available in this testing window under the testing port. Okay, I'll go back. Cross validation. You can see in the right hand side the parameters. Number of folds is 10. I said 10. You can change it. You can make it as a 5. Number of folds should be 5 or number of folds is 20. It is up to you. Okay. So I will divide the data into training and testing. Now what is the flow? Go back and see. So what you have done? You have read the data. You applied the cross validation and you divided the data into training and testing. Am I right? So training data is ready. Testing data is ready. Now what is the next step? What is the next step? How to construct the model?
To apply it in any algorithm.
Very good. You have to apply algorithm on this training data. So we'll go back. Let me say, as I said, there are many predictive analytical models are available. Okay. So Bayesian classification is one of the mostly used predictive analytical model under the classification, and SVM support vector machine, and then decision tree, okay, random forest, and so on. But always I like Bayesian, so I will go for Bayesian. Okay. So if you type Bayes, are able to see that Navy Bayes. Or what you can do, in this folder, we can see there is a folder called modeling. So click this. Under the modeling, you have all your machine learning and deep learning algorithms are available. See, by using this tool, you can build machine learning model, you can build a deep learning model, you can build some generative AI models, everything is possible. You can explore it later. Okay. So now the agenda is to discuss about the predictive models. Are you able to see there is a folder called predictive? Yes?
Yes, sir. Yes, sir.
Yes, sir.
So you just click this predictive. Now you can able to see there are different submodels, lazy model, Bayesian, tree, rules, neural network, okay, and so on, right? So now click this Bayesian, okay, click this Bayesian. I would like to have this Navy Bayes. So just add this. So what happens? The Navy, I will teach you the Bayesian algorithm if time permits, okay? So now you have to supply this training data as an input to the Navy Bayesian. So the Navy Bayesian algorithm will get executed, and by using this training data, the algorithm will get executed and model is built here. Okay. So in the right hand side, you are able to see the model. So you want to connect with the model. I repeat what I have done here. I have applied supervised machine learning algorithm here, Navy Bayesian, okay, on training data, and I got the model. Just I connected this model. Now the model will be in the right hand side, correct? Then what is the next flow? So this part is so first data, then I use cross validation. I divided training and testing. Okay, I applied machine learning algorithm. Now I am here. I got the model. What is the next step? So this is called as this flow is this flow is called as model construction. Model is ready now. What do you want to do? You want to test this model by using this testing data. Okay. So 1 minute. Okay, you'll go back. Now you want to test the model. So what you will do? You will have, there is an operator called apply model. Apply. Okay, the model is built by using Navy Bayesian. You want to apply the model which constructed on the testing data. In this port, you have testing data. Am I right? So connect this model as one input and testing data as another input. Okay. Now model is applied on the testing data. You want to see the performance. Performance operator is there. Performance. What are the performance metrics for predictive analytical models? Anyone?
Precision, recall.
Very good. Precision, recall,
Accuracy.
accuracy. So You know that in predictive analytics, there are two, classification and prediction. For a classification, there are set of performance measures. What are the set of performance measures? Accuracy, precision, recall, F1 score, correct? These are the metrics. For prediction, that is regression, mean absolute error, mean square error, root mean square error, and so on. So if it is categorical data, you will have accuracy, F1 score, precision, and recall. If it is continuous data, you will have mean absolute error, mean square MSE, mean square error, and then RMSE, root mean square error. Clear? But here, what you are trying to do? You are trying to do the classification. So you will use performance. You can see here. You can keep your cursor on the performance. Are you able to see it in the right hand side? Accuracy is there, and recall is there, precision is there. Okay, right? Now, where you are, we are inside the cross validation. Where you are doing all this functionality, you are doing this functionality within this cross validation operator. So you go to the original process, we'll get cross validation. I repeat, double click this cross validation, you will get training window and testing window. In training window, what you are trying to do, you are trying to apply your supervised machine learning algorithm on the training data. The model will get developed. The model will be connected here. Then in the testing window, you are trying to apply the model which you built on the testing data. Okay. Then you want to see the performance. So you added the performance operator. If you keep the cursor, which performance measures you want to know, you can enable it. Okay. Then go back. Now you can see the model. You want to see the model and you want to see the performance. Connect it. Okay. Then once again run the process. What is this? What is this?
Confusion matrix.
Very good. This is called as confusion matrix. So any classification model, any predictive model, what do you want? You want to, how you will measure it? How you will measure the accuracy? How you will measure the precision? How you will measure the recall? You must know the confusion matrix. You must know the confusion matrix. Correct? 1 minute.
Yes,
1 minute. Power. Yes. Yeah. So, you know, everyone knows the confusion matrix. Everyone knows the confusion matrix.
Sir, it's made up of true, positive, true, negative.
Very good. So like this. So we'll say actual A and then predicted. Correct. So actually we'll say this is positive class PC and this is negative class actual, right? And predictor also will have positive class and then negative class. Am I right? So what it means, in the row, you are given actual. Actual means in the given data, the tuple, or you can say the instance, which belongs to this positive class. Like that, in the given data, the tuples or instance belongs to the negative classes. After applying your model on the testing data, okay, because in testing data also we'll have the class label, okay. Then if your model predicted the positive tuples as positive, then it is called as true positive. Positive class is classified as positive. That's why it's true positive. It is correctly classified true. Then here, actually that tuples belongs to positive class. But when you apply your model on the data, it predicted as negative class. So what happens?
True, negative.
Huh?
False
True,
negative.
negative.
False negative.
False negative.
False negative. Your positive tuples are classified as negative. So the second term is a class, negative class. Why it is F? Wrong classification. False. False means wrong classification. Understand? Then what about this entry? Anyone?
False positive. Negative instance falsely classified as positive.
Very good. Negative instances are classified as positive So it is a wrong classification, false positive. What about this?
True negative instance, truly
Classified as a negative instance. Okay. This is called as confusion matrix. So you want to measure the performance of the model. So accuracy. Okay. Accuracy is nothing but take these two diagonals. Okay. So true positive plus true negative, correct, divided by all. Okay, this is a formula, accuracy. Like that, there is a formula for precision, there is a formula for recall, and so on. Okay, what is the error rate of the model? What is the error?
If samples
Error
are
is
misclassification error.
1 minus accuracy. 1 minus accuracy is called as error. Suppose your accuracy 80. Okay, then error is this, it will be 100. So 100 minus 80, it will be 20. Correct? Clear? So this is the way you have to calculate the accuracy. So what happened here? You can see this is a confusion matrix. It says that accuracy is 100%. So positive classes are correctly classified as positive. Negative tuples are correctly classified as negative. So there are 10 tuples in the given data. 4 tuples belongs to positive, 6 tuples belongs to negative. So as per the formula, accuracy is this diagonal, 4 plus 6 divided by all. 4 plus 6 is 10 divided by 10. So it is 1, it is 100%. Since the data is very small, for understanding purpose, I kept this data. But by real time, it will be very large. Okay, clear? So now,
Sir, I do have a doubt in this.
yes.
Could I ask? So when you are splitting the data, you have taken only training and testing, right? You could have considered valid data also, right? Validate data.
I will
So
come
how
to
do
that,
we
madam.
do? Okay,
I will come
CRFT
to
will. Yeah. Okay, sir. Please proceed.
So
Thank you.
what I did now, I have taken a doctor from CMC has given the data, madam. I have divided into training and testing. Okay. And I use the training data to build the model. And then what I did, I applied the model on the testing data. I got the model. Right. Now there is a new data set. There is another data set. Okay. Let me show you the data. What is this? Are you able to see this?
Yes, sir.
Yeah.
So what is the observation here? What is the observation? What is the case study here?
Labels are missing.
Tell me.
Labels are missing.
Very good. So what is the use case here? L sector. What is the L sector? CMC doctor has given some COVID patient data. He asked me to build the model. I build the model. Model is ready. Performance is also 100%. So I want to give this model to the CMC doctor. Now the model is given to the CMC doctor. Okay. Now there are new patients are coming. So you don't want to do all these things. You want to use the model and to classify, to predict whether they are affected by COVID-19 or not. Okay. So I want to predict this. I want to predict this missing labels, missing COVID-19 values for these new 10 patients. Okay. How I am going to do that? So go back and once again read Excel. Read Excel and try to upload the data. Same whatever you have done earlier. Similar process, you follow it. Okay. Now what do you have to do here? What do you have to do here? Important step. You have to change the role. You have to make it as label. Then finish. Okay. Now you got the model, no? So you try to here. I'm sorry. You have to use another one. Apply model. Listen, what I'm trying to do, I build a model. Okay. So I want to apply this model on this unknown data set. I have shown you PPT here. I have shown you PPT here. I have labeled data with labels. I go into the model. Model is get ready. Now I have unknown data where the labels are unknown to me. I want to predict it. Okay. So that is what I'm trying to do here. Now you can see, connect the labels, run the process. What you're able to see? What you're able to see? Are you able to predict the missing values? Yes or no? I hope I'm connected. Hello?
Yes, sir.
Am I audible?
Yes, sir.
Now
Yes,
you
sir.
are able to see this, the prediction. It means that doctor used my model, and by using the model, he is able to predict it. He is able to predict. The first patient, the model says that, yes, he is affected by COVID. Second, he is not affected by the COVID. Third patient, he is not affected by the COVID. Fourth patient, he is affected by the COVID. So this is how he is able to predict it. Okay. So this is how you can build a simple analytical model. And here I used Bayesian classification. I used Bayesian classification. What is Bayesian classification?
Sir, whether it comes under binary classification problem because it is giving the answer yes and no.
It's a binary, madam. Yes, it's binary. It's binary classification only. Two class problem.
Can
Only
we
two
use
values.
this for multiple classes?
Yes, yes. Bayesian will work for multiple class problem. Yes.
Okay.
Suppose I have students, set of students. I want to classify them as excellent, good, and average. Yes, it will work. You prepare a sample data. You prepare a sample data. Try to have multiple classes instead of only two classes. You try to have 3 classes or 4 classes as per your problem, and supply it. This model will work. Okay.
Okay, sir.
So this is how you have to build. Now I want to tell you one more thing here. How you got S here? How you got no here? Now the confidence for S is 1. The confidence for no is 0. Which one is maximum? 1 is maximum. So that's why it is S. So the Bayesian classification, how it works? What is the logic behind this Bayesian classification? Anybody? Quickly.
Bayes theorem.
Conditional probability.
Exactly. Exactly. So Bayesian classification is inferred from Bayes theorem. Okay, I have written here Bayes theorem. Since I have a very short period, I will quickly explain. P of h by x is equal to P of x by h, P of h divided by P of x. Okay, h denotes the hypothesis and x denotes the training data, or you can call it as evidence. You can call it as evidence, correct? Now, which will be computed by using the posterior probability. P of x by h is called as posterior probability, and P of h is called as a prior probability, and P of x is also called as a prior probability, or sometimes in some books, which is also called as a evident probability. Okay. Now, by using this Bayes theorem, the Bayesian classification is inferred. So you can see here, all the h got replaced by ci. So it becomes, the equation becomes P of ci by x is equal to P of x by ci, P of ci divided by P of x. Okay. And this P of x, the evidence probability is going to be same for all the classes. It's a constant. So it will not make any difference in the result. So this equation becomes like this. 1 minute. So this equation is converted like this. P of Ci by x is equal to P of x by Ci, P of Ca. Now what is I here? How many classes you are going to have? Okay. I is equal to 1, comma 2, comma dot m. You ask, no, sir, it is a binary. Yes, because there you had only 2 classes. But in real-time case study, you may have 3 classes, you may have 4 classes, any number of classes. Okay, not an issue. But to understand purpose, you will take 2 classes. So you have to compute. If suppose we have 2 classes, then you have to compute probability of C1 by X, correct? And you have to compute the probability of C2 by X, correct? I'm sorry. Now you have to tell me, you have to find out which one is maximum. If P of C1, the probability of C1 by X is greater than probability of C2 by X, then X belongs to class 1. This is the concept. Then how to evaluate these two? These two parameters is a actual concept of Bayesian classification. The P of X by Ca is computed by using this formula. P of X by Ca. Here in Bayesian classification, you have one assumption. What is that? The attributes are conditionally independent. Attributes are conditionally independent. There is no dependence relation between the attributes. So the P of X by Ca is equal to pi, k is equal to 1 to n, P of Xk by Ca. Now you know that this X is made up of X1, X2, X3, X4, Xn. So I can write P of X1 by Ci multiplied with P of X2 by Ca dot P of Xn by Ca. Okay, right? Then what about this P of Ca? P of Ca is very simple. It is nothing but if the attributes are categorical, it is nothing but the numerator is nothing but the number of tuples belongs to the class divided by total number of data. Okay. If it is continuous, then you have Gaussian distribution, but I don't want to touch it. Okay. In Bayesian classification, I am talking about only how to apply Bayesian classification for categorical data. Okay. If it is continuous data, please go through this Gaussian Bayesian. Okay, by using Gaussian distribution. Okay, you can do that. So quickly, for understanding purpose, I will explain you what happened. It's not moving. Now the same data is taken. Okay, I'm sorry, this is not gold, it's cold. Now this is data and X is given. Okay, this is X. Now what do you have to do? For this X, you have to predict what is the missing label. You have to predict it by using this training data. So what you will do? You will apply Bayesian classification. How many classes we have? 2 classes, correct?
2 classes.
C1, COVID-19 is yes. Class 2 is C2, COVID-19 is equal to no. Is it clear? Now, you have to compute the P of C1 by X, P of C2 by X. Am I right? So first I will compute what is P of C1. What is P of C1? Probability of class 1. Okay, what is probability of class 1? As I said, it is nothing but the number of instances belongs to class 1 divided by total number of data. So in this case, just go through the data. How many instances belongs to S class? 1,
4,
2, 3, 4. So that's why it is 4 by 10. Then P of C2, there are 6 instances, right? 6 by 10. Okay. Now, what do you have to do? This is the X, correct? This is X. So X is made up of X1, X2, X3, X4. So you will take first the probability of fever with respect to class 1. Okay. So how I got 3 by 4? Anyone? This is wrong. This is not 1. How I got 3 by 4?
So for fever equal to yes, how many COVID-19 yes samples are there?
Yes. You have to see there are 4 tuples belongs to COVID-19 is equal to yes. Okay. So in class 1, there are 4 tuples. among the 4 tuples, how many tuples where fever is equal to yes? Okay. So you have to check yes and yes. 1, 2, 3. Correct. So that's why 3 by 4. Now next, you have to compute for with respect to class C2. Why it is 1 by 6? There are 6 instances belongs to class 2. That is COVID-19 is equal to no. Among these 6 instances, there is only one tuple where fever is equal to yes. You can see no and yes, you combination you have to check. Only as per the 7th row. Am I right? Okay. Are you able to follow me?
Yes, sir.
Okay. Okay. Now,
Sir, what about the row 9, sir? Is you saying favor
row
S?
9, then it will be 2 by 7. No, no, sir. See, I am telling. Oh, I am sorry. As per no row 9 only, you have taken 1 row, sir. You are correct. Sir, yes and no. That's why it is 1 by 6. You are correct. Not as per the 7. As per the 9th row, it is 1 by 6. It means
Thank you, sir.
there are 6 tuples belongs to no class. Among the 6 tuples, where fever is yes. So as per the 9th row, this is 1 by 6. What about this one? This is not cold. This is cold. Cold. Here also it should be cold. Okay. So probability of cold with is equal to low with respect to class 1. It is 1 by 4. Like that you have to compute for all these things. That is in X, you have given fever is equal to S. That's why you are computing S, sir. Okay. With respect to class 1 and class 2. Then cold is low. So you have to compute the probability of cold with respect to class 1 and class 2. Then third one is cough is I. So compute probability of cough is equal to I with respect to class 1 and class 2. Then what is the last one? Body pain. Probability of body pain is equal to S with respect to class 1 is 3 by 4. Probability of body pain with respect to class 2 is 1 by 6. Okay. Now what you have to do? You're supposed to compute. As I said, what is the formula? Formula is probability of C I by X. Okay. This is nothing but probability of X by Ci. I'm sorry, I'm not writing properly. Multiplied with P of Ci. Correct. So, see, since you have 2 classes, first we'll compute probability of C1 by X, which is nothing but probability of X by C1 and P of C1. So you take all the class 1 values, 3 by 4. This is not 1, 3 by 4, right? And then only class 1, 1 by 4, and then 3 by 4, then 3 by 4, this one. Okay, up to this. This is P of X by C1. What about P of C1? 4 by 10. So this is P of C1. You multiply this, you will get 0.04218. Like that, compute the probability for C2 by X. Okay, so take all the class 2, 1 by 6, 4 by 6, 2 by 6, 1 by 6. Replace it. And then what is P of C2? 6 by 10. Substitute will get 0.00376. Now, which one is maximum?
Yes, for class, yes.
Class 1 value is greater than. It means P of C1 by X is greater than P of C2 by X. So, X belongs to class 1. So, COVID-19 is yes. So, this patient, the algorithm predicted that he is affected by yes. Okay. So, what happens here? In this tool here, this is how done. you have computed a probability for yes and no. Yes is maximum than no class. That's why it is predicted as S. In the second tuple, yes confidence is, that is probability of S is 0.001 and for no it is 0.99. So this is maximum. That's why it is predicted as clear. This is how you can build a simple predictive analytical model by using Altair AI Studio. Clear? Is it clear?
Yes, sir.
Okay. Now, how to use it in real time? How to use it in real time? See what you did. You developed a prediction model for land use land cover change using spatial temporal data for Dakshin Kannada district in Karnataka. I too worked in NIT Surathkal, Mangalore for 5 years. So at the time, there were, you know that ISRO, the Indian Space Research Organization, they used to release response basket every year. Okay. So what is that response basket? It is like ISRO and academic collaboration work. They will give their problem and you have to submit a project proposal. So like this, we have chosen this problem, land use land cover problem from that basket, but we have the study area which you consider is Dakshin Kannada. Okay. Dakshin Kannada is one of the district in Karnataka. Mangalore is part of it. So what you did here, you did some change reduction. Okay. Change reduction analysis we have done by using our this predictive analytical model, right? And this is the data which you got from ISRO, NRC, National Remote Sensing Center. And you can see in this map, there are different classes. Okay. You said, no, somebody asked, sir, whether it is 2 class or multi-class. See, you can see there are 18 classes here. It is 18 classes. Okay. So you are given this data as input. And these are the, you know that somebody said predictive data means, predictive data analytics means using historical data, you have to predict what will be the today. Okay. Or what will be the tomorrow, right? So like that, you have collected some 15 years of data. Okay. You can see 15 years of data we have collected. And I think it is somewhere I given the data information. Yeah. 2005 to 2015. The data which consists of LULC map, land use land cover map. What is land use land cover? Land cover is your earth surface. Land use is nothing but for what purpose you are using the earth surface. If the earth surface is used for agriculture, the land use agriculture. If the earth surface is used for building, then it is called as building. Okay, right? So land cover is the earth surface and the land use is nothing but for which purpose you are using that earth surface, that is called as the land use. Okay, so here this is a LULC map which you got from NRSC for the year of 2005 to 2015, and you want to predict what will be the changes in the next year. So what you did here, these are the sequence of data, 2005 to 15 year data you have used, and then you have applied our random forest algorithm. It is one of the predictive analytical model. Okay, based on that, you are trying to predict. Okay, how the changes will be. Okay, how the LULC map will be in the year of 2025 and 2035. So this is the predicted output, and this is the actual map. So the predicted training accuracy is 91.31%, and the testing accuracy is 83.61%. Okay, like that. This is the simple linear SVM model. You can see I am showing 2 models. Training accuracy is 68 and testing accuracy is 62. So the random forest is performing well. You got it? So this is how you can apply your predictive analytical models for real-time case study. So I have shown you 2 applications with respect to healthcare and with respect to remote sensing. So with this, I will, because I know that there is a one more session, so I will not take much time. So yeah, you are welcome for queries. Thank you. And this is my mail ID. And if you have any doubt, you are most welcome.
Sir, there is one participant raised their hand.
Yeah,
let
please.
me allow him. Sir,
Hello. Am I audible, sir?
Yeah, you are audible, sir. Please.
Thank you for the engaging session, sir. Being the non-technical participant, it was I did not expect actually that I can understand this much. So thank you for the session, sir. My two question is there, sir. Is this software is open source, sir? Like, is it freely available? Because I have seen the
This software is available in two mode. It is a commercial. When it was released, it was open source, but because of its own demand, now it is commercial. But still, it is available free for faculty, student, and research scholars, sir. So while registering, we have to register as a faculty, and you have to give your institute mail ID. Yes.
Okay, sir. The thing is that if we log in with our institutional ID, so that will work, sir?
Yes, yes, yes.
Okay, thank you. Sir, the next question is that if I want to apply this on the agriculture sector, so in which sector I can use this? Because I have applied random forest and other things with other software. So how I can use this thing?
I'm not getting your question. You want to apply this model in agriculture?
Yes, sir. In case of the agriculture part.
Yes, sir. You can do it. Say, for example, you have did one project. You want to predict the crop yield. You want to predict the crop yield. Okay. So where you have developed a machine learning model and you have used it. Yes, you can use it. No question on that. But only thing is you have to show your data. Okay. You have to show what kind of data you have, what are the features you have, and which attribute is your class level. Are you going to yield the are you going to predict the crop yield, or are you want to predict the disease in the crop? So there are many categories. Let me know your data set. I am ready to help you.
Thank you very much. I will be contacting you. Thank you very much.
Yes, yes. Any other questions? So if you are not finding time now, you can make note of my mail ID. You try to send to this Gmail, because in this official media always I will get a lot of mail from the office. So use the first mail ID and try to send a mail, and whenever I find a time, I will help you. If any more questions, I am ready to answer. Yes.
Participants, do you have any other queries? You can raise your hand, please, so that we will let you.
Sir.
Yes, yes, please.
Yes, sir.
Sir, I have only one question. In this software used for faculty, so you can applying the mail ID is official mail ID or personal mail ID? Yes.
You try to give the official mail ID, sir. That will be better.
Okay, okay. Thank you, sir. Thank you, sir.
Any other queries, participants? Please let us know. So there is no queries as of now from any of our participants. So actually, so to conclude that, I was very much thankful for giving us a very simple and a clear explanation about this predictive data analysis by taking one sample data and to put it into a tool and to see how it was working. I hope that the people who are not recognized about how this was working previously using this machine learning technique, I think they will be really useful with this session. And I can see many people have given us their input, like it was very informative, very interactive. They was very happy, I think so. I hope that you people can actually thankful for you, sir. And also participants, kindly note down sir number. Sir is a very good legend. He has got many funded he got many funded projects also. It means that the implementation, real-time implementation can be done very nicely by sir's advice. So everybody, if you are in need of it, kindly contact sir. Sir is ready to help us in any time. Thank you very much, sir, for giving an excellent talk regarding this predictive data analysis. And
Thank
yeah, they have
you,
given
madam.
their appreciation. Yes, sir.
Thank you, Anita madam. Thank you, Aglandeshwari madam. Thank you very much for this wonderful opportunity. Participants, yeah, you can chat me in WhatsApp or in mail. So I'm ready to help you. Okay. All the best. Take care. Bye.
Thank you, sir.
Okay. Can I leave, madam?
Yes, sir.
Yes,
You
sir.
can leave, sir. I will check
Yeah.
with the other resource
Okay.
person. Thank you, sir. Bye.
Thank you, madam.
Mohanraj, sir, have you joined?
Yes, ma'am, I'm there.
Hello, sir. Good evening. Uh, can you please raise your hand so that I'll make you as a presenter, sir?
Yeah, I'm there.
Thank you, sir. One second, sir.